As humans burn through fossil fuels, carbon dioxide is pumped into the atmosphere. This carbon dioxide acidifies the oceans and warms the planet, causing problems we can't even predict yet. As we scramble to reduce our emissions, one of our greatest tools may have been on this planet longer than we have.
Trees grow and they put carbon into their tissue. They take carbon out of the atmosphere to do that. When they die, the carbon gets into the soil. On very long time scales, some of that carbon can actually be stored in geologic structures underneath the surface of the planet and become things like oil, fossil fuels, and that happened millions and millions of years ago.
Trees, however, are impossible to remove from the ecosystems they live in. Over the course of their lives, they will play out many complicated interactions with the plants around them, with animals, and of course, with fire.
And I don't have the exact statistic, but the majority of forests on the planet have some relation to fire.
In a complex world where the well-being of animals, environments, and human stakeholders must all be considered, can we really get the best of everything? And if not, what should we sacrifice? If we are to maintain a healthy forest, we first need to know what a healthy forest is.
Yeah, you look at the historic record a little further, and Fremont and Kit Carson, those explorers, when they came through, I mean, they were trying to get through in the winter. It had to be much more open, just listening to their accounts. And, you know, some of the photos that we see taken from photo points, even just as recent as 120 to 125 years, the differences between then and now are far greater in terms of less open areas and more congestion with just the amount of vegetation.
It also affects by opening up the canopy, so higher severity fires create canopy gaps that sun-loving plants like pines need, and so like we're seeing in the lower mixed conifer forests of the Sierra, we're losing pine. Probably, at least one of the reasons is probably because we're not creating canopy gaps.
When Europeans arrived in the Americas, they saw fire as a destructive threat. They began a well-intentioned but harmful attempt to suppress it.
By putting out most, if not all, of the fires, we disrupted the natural fire process that had been occurring for millennia.
The thing about these forests is that they need fire to survive. They are sort of the big old trees that you see around us are slowly being choked off and outcompeted by the more efficient and more and the faster water usage of the smaller trees like this.
And when you interrupt that natural process through lightning, for example, which would burn through an area, it would keep the vegetation at bay, it would keep fire behavior wasn't as extreme. Once in a while it would get into a pocket that maybe didn't burn and you'd get some torching, but not to the extremes that we're seeing today. And that's not just here in the Sierras, that's throughout what we're seeing throughout California.
The jury is in. Forests that experience fire usually enjoy lower rates of disease, improved seedling counts, increased fire resistance, and better health overall. But how does carbon dioxide storage play into fire and forests?
Carbon in ecosystems is a cycle, and it cycles through all different, we call them pools, that hold on to that carbon.
The carbon cycle is actually not all that complex. A good portion of it is out in the atmosphere right now, and then the gateway into sort of the cycle portion of it is through plants or trees or even algae that are out in the ocean. And they take the carbon in the form of CO2 and turn it into carbon chains, which they use as plant material and plant energy. And then in turn we use as humans or every other thing that's living on this planet uses for carbon. It's sort of what I like to think of as living carbon. And then we have sort of the end of that phase where we all die. Everything that's been alive dies, and that carbon is released back into the environment, and generally speaking, back into the atmosphere. So trees are the gateway. They're the most important part of that carbon cycle.
Millions of visitors visit this park every year, and when they do, they burn fossil fuels. But that component of the emission inventory is actually very small. It's in the tens of thousands of metric tons of carbon equivalent.
A small portion it is indeed. New reports from NASA and the United Nations suggest that while humans release 29 million metric tons of carbon dioxide annually, there are 55 trillion metric tons of carbon dioxide stored in the world's forests, over 1,800 times the world's annual emissions. However, the emissions from human sources stays in the atmosphere.
Forest fires have never been the carbon problem. They became the carbon problem because, we learned about 100 years ago that there's a compound, buried deep within the earth from previous photosynthetic plants.
If we were to mismanage this forest carbon, for example, through a giant wildfire resulting from decades of fire suppression, it could release massive amounts of carbon dioxide into the air, ruining any human efforts to control our own burgeoning emissions.
We know that these very small trees encourage very severe fire. It's a fire that can actually kill the bigger trees. So it's sort of a twofold double whammy in these landscapes, where we know that fire has to be there, and we don't. And fire gets a bad rap sometimes because when people do emission inventories and they look at fire emissions, generally only the immediate emissions are counted, and the subsequent regrowth of the vegetation is not necessarily taken as to count back against the net. And what we really want to figure out is, what is the net result of the fire? Is the fire actually causing more carbon to be released, or is the net result after many decades is that we are actually increasing the amount of carbon because we're favoring the very large trees? The amount of carbon in a very large tree can equal many, many, many little trees.
This isn't just an idle question. California has passed a law that requires a return to the lower carbon dioxide emission levels of 1990. As a result, there will probably be a drastic reduction in prescribed fires and possibly a ban altogether.
So AB 32 would limit the amount of greenhouse gases industries could release into the atmosphere back to the 1990 levels. And by doing that, that would potentially, maybe not prevent us, but regulate the amount of prescribed fires that we could do in the atmosphere because of a twofold process of fire.
There is one hope, however, that managing a healthy forest and large carbon store can both be done by prescribed burning. A scientific model has suggested that fires that kill off smaller trees allow more growth in larger trees, and that this growth offsets the small trees lost in the fire. To find out if this is true, the National Park Service, along with several other organizations and universities, has launched a study to measure the amount of carbon stored in Sierra Nevada forests.
One of the things that really controls the balance of carbon on our landscape appears to be fire. We don't know exactly what the net effect of fire is on the landscape, but this project is targeted at answering that question.
To conduct this study, Yosemite's Fire Effects Crew, Crew 9, will visit areas throughout the Sierra Nevada, mostly in Yosemite and Sequoia Kings Canyon National Parks.
Sequoia and Yosemite are sort of the two birthplaces of that in the Sierra, and they've been managing the fires and letting them do what they have historically done and prehistorically done to the forest. And so that data set is unique. We don't have places that have many fires overlapping over many decades.
The Fire Effects Crew will take measurements of carbon, such as carbon stored in the soil, tree diameters, tree heights, and tree cores to find out how trees have responded to the fire in the past. These measurements will be taken to the university. There, they will be analyzed for the answers that we seek.
When we talk about sequestration of carbon, and it's less risky to have a very fire-hardened large tree sitting on the ground than to have a whole bunch of these trees which burn very easily. So these are much more liable to be put up in the atmosphere and not come back, because they're very easily burned.
Fires would create greater and greater stability of the forest, greater resilience, and that would stabilize the amount of carbon in those forests, even though it may be less carbon stored in Sierra forests than if you took fire out of the system.
What really matters is not the fact that you sequester carbon, but that it stays sequestered out of the atmosphere. It's good to plant a tree, but it's better to make sure that there's always a tree there. So plant a forest and keep a forest. Change a landscape from a kind of landscape that doesn't hold a lot of carbon to a kind of landscape that does. And that's the stuff that will really make a difference in terms of the overall emissions inventory and carbon balance.
Well, I think carbon ultimately will become more and more of a public issue. It's going to be tackled by individual people, by companies, by our government, and ultimately that'll start playing a role in our park and in our forests. And what I really hope for is that this study and studies like it will show that it's not reasonable to manage our forests for carbon.
In this crazy world of ours, things are never as simple as they seem. Today, we face challenges unthinkable just 50 years ago. Hopefully, if we all work together, we can rise to the occasion, and our forests just might help us do it.